Hi, thanks very much for having me. So, NoSQL's biggest secret. We hear a lot about NoSQL, non-relational databases, and I kind of have a problem with the term NoSQL. But first, before I go into that, I want to introduce you to something I bought recently. It's quite stylish, I think. It's my toaster. And it's a Bosch, so not a bad toaster either. And one of the good things I like about it is it's got redundancy built in. So you can see it's got 2 slots on the toaster. So I can put, one can go wrong, and I can still carry on making toast in the other one. It's not optimized for putting toast in or taking toast out. It's equally good at both. I don't want to say anything bad against Bosch, but it's commodity hardware. You know, there's nothing custom made here. It's just something I bought in a shop. And if I want to make lots of toast, I can make a cluster of toasters as well. I can put a bunch of them in, and even one can fail, and that's okay. The others will carry on working. And you know what? It's 100% NoSQL as well. There's no way I can access any function of this toaster through SQL. And my point here is basically that NoSQL is kind of a silly term. Why have we defined an entire set of database technologies by one thing that they lack? And actually, they don't necessarily lack this thing of SQL. So I want to go back in time a little bit to around 5,000 years ago. This is data. This is one of the earliest forms of human writing that we have evidence of. And it's a clay tablet from Mesopotamia. And our best guess is that it records crop amounts. It records how much someone's grown. And a lot of this type of writing was used for taxation. So the data that we're storing now is, pretty much the same as what we've always been storing. It's about business. It's about what we owe to the government. And so this is one form of data. And then we move on forward a few years, and we get to the 1960s. And there's been lots of steps between there, but we get to the first commercial databases. Now, the first commercial database was Sabre, which was created by IBM and American Airlines to make it easier and quicker to book air travel. And this was a hierarchical database. And hierarchical databases are often called the go-to statement of databases, and you'll see why. Because you always go in at the top, and then you follow links down through the hierarchy until you get to the thing you want. So if we want to find, say, the head of event marketing in this hierarchy, we go in through the CEO, we go down the hierarchy, and that's it. That is the only way we can always go until we find the record we want. And so the way that we query this database is by going, is this it? Is this it? Is this it? Oh, yeah, I've got it now. And that works. There are still commercial systems in place. There's IBM's IMS is still available. XML, the DOM, when we work with the DOM, that is a hierarchical database of sorts. And you'll see this type of database still in finance applications and so on. A little later, though, in the 60s, the Codicil group decided that they wanted to make something a little more sophisticated. So they came up with a network database. And the network database is just like a big linked list. And you can follow the links, not necessarily hierarchically, but from peer to peer. So there's an example of 2 employees together who share a peer relationship. And then 1970, Cod comes out with the relational paper at IBM. And then a year later, his colleagues at IBM come out with the SQL paper. And for the first time, we have a declarative data query language that ends up being adopted widely, and the world changes. Suddenly, we have data in a form in a language that allows us to access that data in all sorts of ways we probably wouldn't have imagined when we first put the data in there. And then in the late 80s and the 90s, we have the object-oriented revolution, and people start saying, why are we normalizing our data? Why are we flattening everything? And we've got these beautiful objects. Why don't we put the objects into a database? And the answer to that question was kind of, nah, don't care. And so the object-oriented database revolution didn't happen. I mean, it kind of did, but not really. But since 2005 onwards, we've had this NoSQL revolution, where we've basically stripped away all of the query stuff in databases and all of the schema and all of that, and said, well, you know, for some applications, we want to optimize for something other than queryability. You know, we might want to optimize for uptime, or availability, or redundancy. And, you know, generally speaking, those new NoSQL databases have just gone back to things from the past. So we end up with key value stores, where the key is our only route into the data, and the value is basically anything you want. It could be a binary, it could be text, it could be JSON. Then document databases, where they have some kind of insight into what is stored in the document. And so there we start to actually get something more towards queryability. And then column stores, which are great for time series data. And then graph databases, which, if you saw Jim's talk earlier, you know, are really just kind of the wizards of the NoSQL movement, in that they allow us to gain amazing insights into data. But other than with graph databases, really the question remains of how do we query this? And the answer a lot of the time has been, well, it's your problem. You're the developer. So I couldn't find a picture of an ostrich burying its head in the sand, because apparently they don't really do that. But a lot of, you know, if you go back to, say, the Dynamo paper from Amazon, it doesn't really describe how to query. It's not interested in query. It's interested in optimizing for other things. But a lot of the systems that we build, we still need to have interesting, rich query. So people came up with ways around that. Manual secondary indexing. You know, you store in a document all of the names of the other documents you want. And then things like using MapReduce to create automatic secondary indexes, or to maybe aggregate data. But really, it's not giving us that ad hoc query that we want. So where do we get declarative query in the NoSQL world? Well, there are kind of three approaches. There's the database-specific approach, which Mongo takes. Then there's these bold new options where something entirely new has been created. And then there's SQL derivatives. So very quickly, JSONic is a form of JSON query language, which is interesting, and it's all about working with sets instead of tuples, but it's never really taken off. Then there's Cassandra's SQL, which is a SQL-like language, but you know, it's very dependent on the underlying data store. So you know, you set a primary key which decides where the the data is stored, and then you set other secondary primary keys, which then decide the ordering. And so you don't actually have an ad hoc query language. You have to understand how the data is stored on disk in order to be able to access it. But for a lot of the things that we do, particularly in web applications, it's all about JSON. It's about storing data as we transfer it on the wire. These are all people called Jason, by the way, just in case you didn't get the joke. And so the University of Berkeley at California put some work into this. And they came up with a paper called the SQL++ paper. And what they wanted to do was they wanted to take SQL, something that we all know, something we're all familiar with and have great tooling for, and turn it into a language that can handle non-relational, semi-structured data, that can handle data that's heterogeneous, and that allows you to put JSON in and get JSON out. So that's what they came up with. They had a language that handles missing data gracefully, that deals with nested data, that breaks the first normal form that says that every single item of data has to be at its lowest point. It has to be an atomic piece of data. You can't nest data. Well, obviously, we do nest data in JSON. And so at Couchbase, we've built Nickel, the non-first form query language, and it just happens to be, so we found out, SQL++ in practice. So to let you know about Couchbase, we're an open source distributed database company that basically gives you a document database that has memcached built in, also gives you a key value store, and now has Nickel. And we've just set up a team in Spain. We're present in Madrid, Barcelona. You know, you can see us in all sorts of places like Walmart and Tesco in retail, and then PayPal, one of our biggest users. So it's in very big scale operations. So Nickel's the new thing though, and it's basically SQL with some extras. So let's very quickly have a look at how it works. This is a profile. This is me in JSON format. We want to find all the people from our London office at Couchbase. That is what you would type in Nickel. It's just SQL. And it gives us this sort of result back. It gives us JSON back. But it is JSON, so it's nested. So we want to find inside an array in that JSON. So we handle it like an array. We specify, go to level 0 and find me the name key. So there we have all of the events that the people in this team are going to, my team that I work on. You'll see there's some duplication. You'll see that there's some missing blank results as well, because, it's schema and enforces. There will be missing data sometimes, and that's fine. So we can handle that by saying, well, give me everything where conferences isn't missing, and then our data results are a little bit more clean. And then we can do something like, well, actually dive into some of that nested data and find me anywhere that the conference satisfies the name DroidCon Sweden. And we get all the people who are going to DroidCon Sweden. Great. OK, so it lets you do all the other stuff that you would expect from SQL, like deletes, inserts, updates. But there's one thing missing. We haven't spoken about joins yet, because you don't do joins in NoSQL, do you? Well, actually, you do in Nickel. So let's have a look at something more interesting. Here's an airline. Here's an airport. And there's a route that an airline, United Airlines, takes between Heathrow and San Francisco. So we have that in JSON data. Let's do a join on it. Let's find out who flies from Heathrow to San Francisco. So you can see that what we're doing is we're looking for anywhere in these documents where the source airport is LHR, the destination is SFO, and then we do that join. So what we do is we find, out of those documents that we've retrieved, on the one side of the join, we find where the airline ID in those documents matches on the other side of the join, what we call an A, matches that key name. So that gives us, and if I just pop into our REPL interface, that gives us, that gives us this kind of result. So that gives us the names from 32,000 documents of all the airlines who fly that route. And what we've done there is we've basically taken the route data and then joined on to the documents that describe the airlines. So let's turn it into something a little more useful. This one here, now, it's almost a three-sided join, because what we're doing is we're unnesting that nested data, the schedule information. So on the route, as in the document up here, what we have is we have nested in there a bunch of flights on different days at different times that airline runs on that route. So what we'll do is we'll now bring that out, bring it up to a top level, and use that as part of our query. So what we can do is we can say, we call that side of the join S now, and we can filter out only the flights on a Monday, and we'll order it by the time that they leave. So we'll put that in there. And there you go. We now actually have something that would be usable in a real web application where we can find all the flights going from Heathrow to San Francisco out of 3 different types of document. We're joining them together. We're pulling data out that's nested in there and using that. And it's just SQL. And it works at scale, and it's familiar. It works with JDBC, ODBC. If you're interested in talking about it, then we're around. We're going to run a workshop in Madrid soon. And it's all open source. You can find it on GitHub. And we have a really quite cool developer community. So if you want to find us online, we are at developer.couchbase.com. The SQL++ paper has a really long link, so just Google SQL++ paper and you'll find it. And if you're interested in kind of talking in more depth or learning more about Couchbase and asking us about it, then come to forums.couchbase.com. If you want us to come to your meetup or run a workshop with you, then find us around at the event. And thank you very much for your time.